Hey guys, this is going to be the video walkthrough for the second section of chapter 14. So we've been talking about single case research design or single subject or single case experimental research design. And so we're going to talk about two important components of that design today, which is phases and phase changes. um, so this is going to be learning objectives 3 and 4 from your chapter. So we're going to talk about the purpose of a phase and how patterns within the phase are defined, including the importance of the data being stable or the stability of the data or the pattern. And then we're going to talk about how researchers identify a significant, air quotes around significant, difference or meaningful difference between two phases in a single case experimental design. So um, let's talk about phases. So phases are the building blocks, basically, of this design, this research design. Okay. And so um, what it is a series of observations of the same individual under the same conditions, which you kind of already knew. That's what a single case design involved. But those series of observations are called a phase. Now you know that term. Um, it changes when the treatment changes, or something is manipulated or taken away or whatever. And so um, an example of the phases is before treatment, during treatment, after treatment, stuff like that. The baseline, this is another term for you, phase or baseline observations, that is before, that's the before phase, right? So that's before any manipulation or treatment has been um, introduced, and that is one of the main requirements for a single case study design, because you need um, that baseline in order to have something to compare, in order to establish that cause and effect relationship that we're looking for in this experimental design. So, baseline observations, again, are made when no treatment is being administered, and you can go back to the baseline phase if you remove the treatment as well, but this has to occur first, obviously. Um, and so that series of baseline observations is called the baseline phase, and it is identified by the letter A in, like, research reports and graphs and data reports and things like that. So if we have the baseline phase, then we also have treatment observations and treatment phases. And so this is obviously when the treatment or manipulation is occurring. And so remember, treatment doesn't always mean clinical. Remember, that can just mean a manipulation of an independent variable. Um, and so the series of treatment observations is the treatment phase. It's identified by the letter B. And so also, there can be different treatments or different manipulations or different conditions, and that those different phases are going to be different letters. So there could be B, C, D, etc. So these letters allow researchers to describe the phases in a study. Like I said, in a research report or in a graph, it allows them to talk about it. So in your book, it talks about right here how the example from 14.2 from the last video, where they talked about the disruptive children or disruptive child and the treatment example, and they had a baseline, so they had A, and then they had a treatment phase, and so they had a B. And so I think it says, yeah, right here it says the example in 14.2 would be called an A-B design, because it was a baseline phase followed by a treatment phase. Okay. Now, there are lots of other variations that can occur. Figure 14.1 at the very, very beginning of chapter 14. I won't jump back to that right now because it'll take me way off, but you can flip back to that if you want, and look that back up. But that was an example of a remember they did the tootling. They had a baseline, so it was A. Then they did a tootling program, and they observed the disruptive behavior in the child, so they had a B. And then they removed the tootling program again, told the kids not to do that anymore, and so that was back to baseline, so that was back to A. And then they did the tootling again one more time to establish that replication, and that was B. So that's an ABAB design. Um, Here, it also talks about that you could do, and this is very complicated. It says A, B, B1, A, B, C, and C design. Okay, what that would mean is that there was a baseline A, they did baseline observations, then they went into a treatment phase, they introduced a treatment B, then they made some sort of modification, some sort of small modification to treatment B based on what they saw in the first phase. And so then in the second phase rather. And so in the third phase, they did B1, which was a modification of B. And then they removed treatment altogether back to baseline A. And then they wanted to try treatment B in combination with another treatment C. So they did both of those at the same time. And then they removed the treatment B and just did C by itself to see what that would look like, to see what they could observe in behavior that way. And so that is what all of those crazy letters mean in that example. Okay. And obviously they're not always that complicated. It just depends on the experiment. Okay, so the purpose of a phase, again, is to establish a clear picture or a pattern of behavior for the conditions of that phase. So we can have something to compare so that we can see if the treatment is actually having an effect. And so in order to convincingly do that, in order to do that in a reliable and somewhat valid way, there has to be some sort of established parameters here. And so one of those things is for the baseline phase, especially, but for phases in general, there needs to be a consistent level or a consistent trend before you can move on to the next phase. Again, so that you can have something reliable to compare it to. And so when we say consistent level, what we mean is a series of measurements that are all relatively the same magnitude. And it says graph data points cluster around a horizontal line. So let me show you what that looks like. That is graph A here that says stable level. So you can see how they do vary. Of course, behavior is going to vary. So of course, each day here, they've measured them one day, each day for a week. And each data point varies a little, but they all are generally around a similar line. It's not like on day 4 or 7, it goes all the way up to the top or something crazy, right? And so that would be consistent level. Consistent trend, on the other hand, is not a horizontal line. It is still a line, but it is a sloping line, like when we looked at correlations. So the differences from one measurement to the next they're still consistent, but they're just in a similar direction, and again, nearly the same magnitude. And so it says they cluster in a graph around a sloping line. So that is B here. This is a trend. And so obviously it can't be both. So we want either a consistent level or a consistent trend, a stable level or a stable trend. Either A or B is great. Now, C is where we can get into trouble, which we will talk about in just a second. So what is the thing that holds those two together? What's the commonality here? And you've heard me say it, it's stability. So stability is the degree to which the observations are showing that consistency, that consistent pattern or consistent trend. So you'll hear stability and consistency kind of interchanged a lot with this. So stable data, it shows only minor variations. Yes, there's going to be variations, but we want them to be minor, so that overall it is a pretty consistent pattern. So again, variation should be relatively small and a linear pattern relatively clear. As you can see from graph C, the unstable graph down here, there's no line there, right? That is all over the place. There is not a consistent pattern there. So how, and so if that is there, then how would, if that's what you have for your phase, how can you see if a treatment or a change in phase is going to affect anything if there's nothing stable or consistent beforehand to compare it to, right? So, like if we changed, so if this was our baseline in graph C, and then we introduced a treatment, we manipulated something, and we observed them again, and it was all over the place again. Well, we're not going to be able to view all the data is all over the place. There's no consistent pattern. So, how are we going to be able to compare to see if it made a difference? So there has to be an established pattern in order for us to determine anything. So how do we deal with unstable data then? One of the strategies is waiting until the data stabilizes. The example of that is if initially during the observation process, the participant is the novelty of it is causing them to behave differently, and so their behavior isn't consistent. But if you wait a little while and continue the observation process, eventually those observations level out into a consistent pattern once they go back to their normal behavior. And once that, so then you can just continue to maybe observe longer than you anticipated, but eventually, if you establish if it starts to be consistent, you start to see that pattern, then you would be able to call that stable and move on to the next phase. Another strategy is averaging a set of two or more observations. And so an example of that is right here in figure 14.4. So you can see here that in graph A is the original unstable data. Again, very unstable. It's all over the place. In B, you can see it looks more like a line now. And so it looks more stable. It is the same data points. Hear me, that's the same data. It's not a different data set. What they did, if you look at the horizontal axis, the day of observation, what they did was they averaged day 1 and 2 into one data point. And then they took data points for 3 and 4 and averaged them to one data point. And then they took 5 and 6 and added them together, divided by 2. That's how you average it, right? And they got one data point for that. And then day 7 and 8 and day 9 and 10. So now instead of 10 data points, we have 5. And it establishes a more stable pattern for us to use as a comparison when we change phases. Another strategy for dealing with unstable data is to look for patterns within the craziness, within the inconsistency, right? And so going back to graph A here, this craziness here, to a certain extent, you can see it goes up, down, up, down, up, down, up, down. Not totally consistent, but fairly consistent. It's going up, down, up, down, up, down. So you have to ask yourself, why we measure them one day, the next day it goes up or down, and then the next day it reverses again. Why is that? And if depending on what the behavior is, or what the variables are you're looking at, you may be able to determine what's causing that. An example of that in your book was when they were looking at the disruptive behavior, they noticed that Monday, Wednesday, Friday, there was a consistent pattern, but Tuesday, Thursday, it was different. And they noticed that Tuesday, Thursday, their observations occurred after the kid had participated in gym. So their theory was, what if gym is causing them to be less disruptive? So we needed to remove the gym variable. It has become an extraneous variable. We want to remove that out of the equation. So we want to control for that. So we either move our observations into the morning before gym so that every day is the same. There's no gym beforehand. Or you can only measure on non-gym days. Just only measure on Monday, Wednesday, Fridays and see if that stabilizes the data. Either of those scenarios could result in a more stable pattern, and then you would be good to go. So unstable data can just end up being, I mean, it may just be unstable, but it also could be extraneous variables. And so if you can look for those patterns within the inconsistency, within the craziness, um, then you might be able to identify the extraneous variable like Jim and control for it and remove that as an influential variable and stabilize your data. Okay, so the other thing we have to talk about is the length of a phase. So what determines how long a phase is, right? How many observations you do. Um, basically, until a pattern has been established. You've heard me allude to that already. Um, so um, there is a minimum though. So you have to have a minimum of 3 observations, right? Um, because 2 observations is not going to provide enough information to determine a pattern. Um, if we go back to our examples here, um, you can see that the differences between day one and day two in all 3 graphs is pretty much the same. So if we only looked at day one and day two, we would have no idea if we were looking at a stable level or a stable trend or an unstable behavior. We would have no idea because they all look the same. It's when we increased our observations from 2 to 3, 4, 5, 6, 7 to where we can see these trends. So additional observations beyond 2 are necessary, essential, to be able to see the level and the trend and the stability of the data. Typically, so 3 is the minimum, but most researchers are going to do 5 or 6, um, because that's usually what is necessary in order to see a clear pattern. When there's lots of variability in the data, again, you may need to do longer observations, more observations, to until you see that clear pattern emerge. The number, how many observations? Well, that number just depends on how many it takes to establish stability, right? How many observations it takes until you can see a consistent pattern. Then once that happens, you can change phases. So changing the phase means that we are introducing a treatment, so we're implementing the treatment, or we're removing the treatment and going back to baseline, or we're changing the treatment a little bit. We're either adding 2 treatments together, or we're tweaking this treatment a little bit, so it's that B sub 1 that we talked about, whatever the case may be. But either way, it is something is changing, and that's initiating a new phase, a new letter, right? A, B, C, whatever, where the researcher can collect observations under these new conditions so that we can compare to see if that change causes an effect in the behavior. It's to demonstrate that that change produces a noticeable change in behavior, right? That's our goal here, is to establish that cause and effect relationship. So how do we decide exactly when to change phases? Again, it's when a clear pattern has emerged in the phase before. So it is based on the participants' responses and their behavior, and that's how we determine it. There are 3 things that need to be considered when doing this. One is if they are improving without treatment, then don't implement the treatment. What that means is if there's a positive trend in the baseline, they are already showing improvement in their symptoms in a clinical setting. If they're already showing improvement, then introducing the treatment could disrupt their improvement. And so, from a clinical perspective, it's good for them that they're improving on their own. Let them continue to improve and then see what happens. Don't introduce a treatment that could possibly be detrimental to them. From an experimental standpoint, it is also not a good idea to implement the treatment because if they're already increasing or improving their behavior, um, and you introduce the treatment and it continues to improve, how do you know that the treatment had any effect? They may have, if you hadn't done that, they may have continued to improve on their own. So you have to, again, have something to compare. And so if they're already improving on their own in the baseline, then you can't really establish whether or not that treatment's going to have an effect. And so it is better to let them improve. And then if it levels off at some point, and has that stable level, then you could introduce the treatment. Um, or if they start deteriorating, which this is the other thing to consider here. If they're deteriorating quickly in that baseline or in whatever phase they're in, then you need to change into a different treatment or implement the treatment if they're at the baseline, or if they're doing some other treatment, change the treatment to something else immediately. You don't wait. Well, we were going to do a minimum of 5 observations. Don't wait for that if they are deteriorating quickly, because again, this is an ethical consideration. It's not okay if they're declining in their mental health or in their behavior or whatever it is. You want to implement something, a change that's going to help and benefit them immediately. You can always go back to the baseline later if you want to have a longer baseline to compare it to, or you can always go back to that other phase if you want to compare it again. But if you notice that quick deterioration, you need to change immediately, and then again, maybe you can go back to it later, but you don't want to harm, right, the participant. And the last thing to consider is if the treatment produces immediate and severe deterioration. Oh, well, yeah, that's kind of the same thing. I've already I segued into that without even realizing that I segued into it. But yes, you need to cease or modify that treatment immediately. Um, so the second bullet point there was actually only referring to implementing a treatment from the baseline. And then the third one was actually talking about if you weren't necessarily in the baseline phase. But either way, whatever phase you're in, we obviously don't want to do any harm to our participants. Um, so um, the most convincing results, like how do we interpret results? The most convincing results is when the change in the pattern is immediate and large, right? Like the graphs we've looked at where they were all, you know, high and then the treatment occurred and then they were all low. All the observations were low. Big immediate change. But that doesn't always happen. And ultimately, this is a subjective interpretation as to whether it's meaningful or not. Um, so there are 4 characteristics that have been determined that help us figure out whether there's a meaningful change between phases or not, whether it is, quote, significant or meaningful. Um, and so one of the first things is a change in the average level. An example of this is right here in figure 14.5. So you can see this dotted line, the horizontal red dotted lines. Those are the average. That's an average of all 5 days of observation. Okay, so that's why there's 2, and that's like the line of best fit almost. It's the average there, and so um, you can see that if you're comparing baseline A's dotted line to baseline B's dotted line, you can see that there is obviously a very large difference between the 2 averages. And so that can help you visually see that a little bit better. There's also, you can also look for an immediate change in level. So back to this, if you look at the 2 endpoints between, or that are on the either side of the introduction of the treatment, which is the vertical dotted line, right, between day 5 and 6. If you look at the data point for day 5 and you look at the data point for day 6, you see this giant jump, right? Because up until this point, 1, 2, 3, 4, 5, they were all relatively the same. And then suddenly on day 6, it jumps way up. So comparing those 2 scores before and after the treatment, the immediate scores before and after those data points, that can help you see if there's that immediate change in level, and that can suggest that there is a meaningful, significant effect here. A third way is the change in trend. So if we scroll down to 14.6, you can see in A, in graph A, there is a change in trend. Whether it went from a fairly stable level here in baseline A, and then all of a sudden we're doing a trend going upwards, right? For treatment B. If you go down to graph B, the second graph underneath that, this trend changed from positive to negative. So it was still a change. It went in the opposite direction. So we were going in a positive direction, or going increasing in whatever that behavior was in baseline, and then when we introduced the treatment, suddenly that behavior is going down, which hopefully that would indicate like symptoms of some sort of mental illness or whatever. And so their mental health that would show an improvement in mental health, if their symptoms are going down after treatment. And so that change in trend is another way to determine whether or not there's a meaningful effect occurring. And then the last example or characteristic that we can look for is the latency of change. And so to give you an example of that, we're going to look for figure 14.7. Let's see if I can find it. Oh, wait, it's right here. 14.7. Here we go. And so you can see in graph A that there is an immediate change in the trend when the I just lost my train of thought. When the treatment is introduced, in B, in graph B, the one below, you can see that the behavior is remaining at the baseline level for several days after the treatment is introduced, and then it starts to go down around day 8, 9, and 10. So what latency of change means, think late, delayed, okay? So in graph A, the top graph there, that immediate change on day 6 is a good indication that there is a meaningful thing happening. In graph B, it is occurring later. It is not, the change is not occurring immediately. It's not on day 6 or 7 or 8. It's day 9 and 10 that it starts to go down. So the problem, so this, when there's an immediate change, that latency of change is not there. That means that there's probably something meaningful, right? But in B, we don't know for sure that the treatment is causing that decrease on day 9 and 10 because it did take so long for it to change. And so more modifications of treatment or more replication is going to be required. More observations are going to be required in order to have confidence in the cause and effect relationship for that particular set of data. Okay, so that's the 4 things you can look for. And then, so the knowledge check is next, and we're going to actually go over to the learning check in your book because it covers one of those questions. Oh, poop, I went too far. Okay. So learning check. In a single case design, what is the series of observations called when no treatment is being administered? So no treatment, remember, is the baseline phase. So remember that term, baseline. Which of the following is the definition of a treatment phase? So if you look at these answers, you can really just look at the very first few words. A phase is not a boundary. It is not an amount of change, especially between final observation and first observation after. That doesn't apply. And then it's also not the first observation because it is a phase. So it has to be a series of observations. And the treatment phase, obviously, is when the treatment is being administered. And then last is, how are the results from a single case study typically evaluated? And hopefully from this video alone, you can realize that it is a visual inspection of a graph. There's no standard deviation calculations. There's no inferential statistics like hypothesis tests and significance tests. It's not a consensus among at least 2 researchers. As we have shown in this video and the others, it is a visual inspection of a graph, is how single case studies are evaluated. So that is it for 14.2. And again, I'm here if you guys need anything.